Hello guys, welcome to another concept of our studies on rational function. Particularly today, we are going to deal with another important aspect of our studies, that is on partial fractions, which is one of the most important concepts of algebra when it comes to high school math education. Now let's proceed to the introduction to partial fraction. In algebra, the decomposition of complex rational functions into a sum of simpler and separate fractions is known as partial fraction. It helps in simplification and analysis of functions. A partial fraction decomposition is the process of expressing a rational functions of the form r of x equal to px divided by qx as a sum of simpler and separate fractions such as a constant divided by a linear function or linear expression of the form s minus a plus a constant b divided by linear expression of the form s plus b plus a constant c divided by a repeated linear expression of the form s plus a, and so on. So you are going to analyze that this separate rational function is being added together to produce a single rational function. So the decomposition of this rational function, which is p of x divided by q of x, into separate rational functions of this nature is what we call partial fraction. Now, let's look at the key conditions for partial fraction decomposition. So if I have a rational function and I want to decompose it, break it down into separate fractions, what are the key conditions to consider? Number one, the fraction or the rational function, so the denominator of that particular rational function, supposed to be factorizable. So one factorizable denominator. So here the denominator must be completely factorized into linear or irreducible quadratic factors. So you have to note the denominator of that particular rational function and see if it is completely factorized or if it is in the form of irreducible quadratic factors. Then let's look at the example of the first condition. If we have x squared minus x minus 2, this expression can be reduced or completely factorized into a format of x minus 2, x plus 1. Then let's look at another example here. We have x power 3 minus x squared plus x minus 1. This cubic expression can also be reduced or completely factorized into an expression of x minus 1, x squared plus 1. So when you look at this x squared plus 1, it is a quadratic and it can never be reduced again. So we call this one irreducible quadratic factor. So here, the second thing that you need to consider before decomposing a rational function into separate partial fraction is to note that the rational function is a proper function, a proper fraction rather. So we are going to consider proper rational function. So here, the degree of the numerator must be less than the degree of the denominator. So anytime you have a rational function and the degree of the numerator is less than the degree of the denominator, then indeed that rational function is a proper rational function and can be decomposed into separate fractions. So let's look at example. We have 4x minus 5 divided by x squared minus x minus 2. We also have 3x plus 1 divided by x power 3 minus x squared plus x minus 1. We also have, when we look at all these examples, the degree for the numerator here is 1 and the degree for the denominator here is 2. So it makes this particular rational function a proper rational function. So here, the degree for the numerator is 1 and the degree for the denominator is 3 because the highest powers of x here is 3 and the highest power of x here is 1. It makes this particular fraction a proper rational function. Look at this one too. The degree for the numerator is 2 and the degree for the denominator here is 3. So this particular function or fraction becomes a proper rational function. Now the third condition here is if the fraction is improper. Now listen, if the fraction is improper, it means that it must first be expressed as the sum of a polynomial and a proper fraction. If the fraction is improper, then it means that I need to express the fraction as a sum of a polynomial and a proper fraction before I can separate it completely. Now, example, look at this particular expression. We have 2x squared plus 1 divided by x plus 1, x plus 2. The degree here is 2 and the degree here is also 2. It makes this particular fraction an improper rational function. Now, what I'm going to do is I am going to use division approach to reduce it into a sum of a polynomial. So here, this is a constant polynomial plus another polynomial, which is now a proper rational function. Then I'll work on this rational function as a way of separate simple fraction. Okay, now these are the three main conditions that we need to consider before decomposing a rational function, a single rational function, into a separate rational function known as partial fraction. So let's repeat the conditions again. One, we have to get a factorizable denominator. Then second, we need to know that or understand that we are separating a proper rational function into a separate rational function. Then three, if the fraction is improper, it must be expressed as the sum of polynomial and a proper fraction. Good. Now, why do we use partial fractions? Why do we use partial fractions? So, what is the concept about it? What do we use partial fraction for? The first one is to simplify rational expressions. We use partial fractions to simplify rational expressions. That is the first one. Then the second one is to make integration easier in calculus. So when you have a rational fraction which look complex, when you separate them into separate partial fractions, integration becomes easier. Now, to solve rational equations, we also use it to solve rational equations. It makes the solution for rational equation very simple. Then the three, to model system in real life problem like electrical circuit or fluid flow. So now, example is the fraction 2x plus 1 divided by x minus 2, x plus 3. It looks complex now. This one can be split as 1 over s minus 2 plus 1 over s plus 3. We are going to learn on how to do it in a simplest form. So now, splitting or decomposing rational fraction, which is having a denominators with linear factors. So how do we split a rational fraction with denominators which is in the form of a linear factor? So the next thing that we are going to study now is splitting or decomposing denominators of rational fraction with linear factors. So now let's see something here. When the denominator of a rational function consists only of linear factors of the form. Look at how linear factors mean. It means that the factor is of the form s plus a or s plus b, s plus c. The function can be expressed as the sum of partial fractions with constant numerators as shown below. So here, this is the nature of the separation that we are going to see. P of x divided by x plus a, x plus b, x plus c, where this particular rational function is a proper rational function. Then this rational fraction can be split as a divided by x plus a plus b divided by x plus b plus c divided by x plus c. What it means is that if the denominator is completely factorized in the form of linear factors, as you can see here, then we use a constant term to separate the linear factors. So if I have x plus a, I will use a constant term a to separate x plus a in this nature. If I have x plus b, I'll use a constant term b to separate the x plus b in this nature. If I have x plus c, which is linear, I will use a constant term c as my numerator to separate the x plus c. So we use constants to separate linear factors. So now here, a, b, and c are constants to be determined. So steps for decomposition when you have linear factors as your denominator. Now these are the steps. 1. Factor the denominator completely if not already done. Listen and do it in that way. Then 2. Write partial fractions with unknown constant over each linear factor as it has been done here. So these are the partial fractions with unknown constant a, b, and c with 8 linear factors. Then 2. Multiply through by the common denominator to eliminate the denominator. So the concept is you are going to eliminate the denominator. Then 4. Use either of the following method to find the constant. So what are the methods that we use to find the constant? We are familiarized with it because we've already learned about the concept of identity in algebra. So now we are going to use cover-up rule or expansion and equating coefficient. If you've not watched the previous video, go and watch the video on identities. You are going to understand the cover-up rule and the expansion and equating coefficient. Now, let's work on simple example to understand the whole concept of what we are studying. We have an example here. We solve 6 divided by x squared minus 9 into partial fraction. This one is a rational fraction. Ask yourself this question. What is the degree of the numerator? The degree is 0. What is the degree of the denominator? The degree is 2. It means this one becomes a proper rational fraction. So we can separate it easily. Now, the first concept is to factor the denominator completely. So we have the denominator of x squared minus 9. How do we factorize this one completely? This one is difference of 2 squared. So factorizing this one completely will end us with x plus 3, x minus 3. Then write partial fraction for this particular linear factors. So here, 6 over x squared minus 9 is equal to 6 divided by x plus 3, x minus 3. We have linear factors. And what do we use to separate linear factors? Constant. So here, a divided by x plus 3 plus b divided by x minus 3. So we've separated. We just have to find the value of a and b. So multiply through by the denominator. So here, when you multiply through by the denominator, this one, we are going to end up with 6 equal to a, x minus 3 plus b, x plus 3. Then use cover-up rule. So the cover-up rule, we are going to let x equal to 3 in order to cover up a to get b. That means sending a to 0, in order to get b. So doing that, we have 6 equal to a 3 minus 3 plus b 3 plus 3. That will give us 6 equal to 6b. Then b will give us what? 1. Then let s equal to minus 3 to cover at b to get what? A. So in that same order, 6 equal to a minus 6, 6 equal to minus 6a, or divide both sides by minus 6, then a will be minus 1. As such, it means our constant a is minus 1 and b is 1. Hence, we are going to split it in this form: 6 over s squared minus 9 equal to minus 1 over s plus 3 plus 1 over s minus 3, which will give us 1 over s plus 3 minus 1 over x minus 3. So this is how this particular rational fraction has been completely separated into sums of separate what? Fractions. So here is the first example. Now let's proceed to the second example. We are supposed to decompose 3s plus 2 divided by s squared plus x minus 2 into partial fractions. So here the solution: s squared plus x minus 2 is equal to s plus 2 x minus 1. Now we've completely factorized the denominator into this format. Then how do we separate the linear factors? Using a constant: a divided by s plus 2 plus b divided by s minus 1. Then multiply the LCM, which is this one, by each of the term. So when you multiply this by this and this is going to cancel. Then we are going to have 3x plus 2. When you multiply the LCM by ax plus a divided by s plus 2, the s plus 2 cancel the s plus 2. Then we have a bracket s minus 1. Repeat the same thing: the s minus 1 cancel the s minus 1. Then we have b bracket x plus 2. Then at the end, we are going to have 3s plus 2 equal to a bracket open s minus 1 plus b s plus 2. Then let s equal to 1 to cover up a to get b, and that will give us 5 equal to 3b, and our b will be 5 on 3. At the same point, we want to cover b to get a, so we are going to let x to be minus 2 so that b will go to 0. Doing that, we are going to have minus 4 equal to minus 3a. Divide both sides by minus 3, then we have a to be 4 on 3. We are then going to substitute this constant as our a and b, and we will end up with 4 over 3 s plus 2 plus 5 over 3 x minus 1. So this is how this particular rational function has been separated into separate rational function as a sum of separate rational function, and that is what we call partial fraction. Nigeria WASSCE 2025. Question 4. We are to resolve 2x minus 7 divided by 25x minus 24 minus 6x squared into partial fraction. So this is a try section for you, and we are also going to decompose the following into partial fractions. So we have example 1, 2, and 3. So the hint is that factor the denominator first for this particular question. So these are some student practice section for you to try your hands on. So pause the video, try your hands on these questions, then send us your feedback before proceeding to the next section of the studies. Now let's proceed to the next section of our studies. Here we are going to learn on how to decompose denominators with quadratic factors. So the first one that we studied was decomposing denominators with linear factors. What if we have quadratic factors? Factors that cannot be reduced again into linear format. How do we decompose it? So now, let's proceed by understanding that when the denominators of a rational function contains a non-factorizable quadratic expression like s squared plus 1, imagine you cannot reduce this one separately into real number format. It is a quadratic expression that is irreducible. into separate factors. So the corresponding partial fraction takes the form. So if I want to separate a quadratic factor which is irreducible into a separate factorizable form or a separate linear factors format, then that is how we are supposed to separate it. P of x divided by x plus a divided by x squared plus b. Here, this one is a linear factor. And what do we use to separate a linear factor? We use a constant. So if the denominator is having a linear factor, because the unknown variable x is raised to the power 1, and we are separating it using a constant, then if we are also having a quadratic factor, then we can also separate the quadratic, the irreducible quadratic factor, with a linear expression. So here, this quadratic factor, which cannot be reduced into separate linear factor, will be separated by using the format bx plus c, where bx plus c is a linear expression. So we use constant to separate linear factor, and we also use linear to separate quadratic factor. Good. So here, x plus a is a linear factor, so constant numerator a. X squared plus b is a quadratic factor, so we use linear numerator bx plus c to separate it. So now, steps for decomposition of partial fraction or rational fraction with a quadratic factor. Identify the linear and quadratic factors in the denominator. That's the first step. Second step, assign partial fractions with constant numerator over linear factor. So a over linear factor. Linear numerator over quadratic factor. So linear numerator bx plus c over quadratic factor. Then 3, multiply through by the common denominator. Use substitution when applicable or coefficient comparison to find a, b, and c. So now, let's proceed to some simple examples. So number 1, we are supposed to decompose 3x plus 1 divided by x plus 1 bracket open x squared plus 1 into partial fractions. Here, look at something here. Identify the linear and quadratic factors in the denominator. So look at the denominator. We have linear and quadratic. So we have x minus 1 is a linear factor. X squared plus 1 is a quadratic factor. Assign partial fractions with 3x plus 1 divided by x minus 1, x squared plus 1. So I'm going to split the linear with a constant, the quadratic with a linear. So a divided by x plus 1 plus bx plus c divided by x squared plus 1 multiplied through by the common denominator. So doing that, we are going to end up with 3x plus 1 equal to a, x squared plus 1 plus b, x plus c, x minus 1. So here, what is the next step? Use the cover up rule to cover up one of the constant to get the other. So let x equal to 1 to cover up b and c to get a. So as such, we are going to get 4 equal to 2a and a equal to 2. Then the same thing, expand the right hand side. When you expand the right hand side, we are going to get an expression of this nature. That is ax squared plus a plus bx squared minus bx plus c, x minus c. Then group like terms, we are going to have a plus b all in x squared plus minus b plus c all in x plus the constant a minus c. Then compare coefficient on both sides. So when you look at here, we don't have x squared at this side. So it means a plus b is equal to 0. There's no x squared coefficient here. Then we also have here x coefficient here to be 3. So 3 will be the same as minus b plus c. But if a plus b equal to 0 and a is 2, then b is equal to minus 2. So the same thing, a minus c is equal to a constant 1. So it means c is equal to a minus 1. Then c will be 2 minus 1, which is equal to 1. So here, the final answer of our splitting will be equal to the constant 2, which is a, divided by x minus 1 plus minus 2x, because b is minus 2x, minus 2 rather. So minus 2x plus 1 divided by x squared plus 1. So this is how we've been able to split the rational fraction of the form 3x plus 1 divided by x minus 1, x squared plus 1, where x squared plus 1 is a quadratic factor which cannot be reduced into linear factor. So here, let's proceed to the next example. Express h of x in partial fractions. So look at it. This one is a proper fraction, so we can separate it. Now, solution. This one can be expressed as ax plus b divided by x squared plus 2x minus 5. Why? Because x squared plus 2x minus 5 can never be reduced into a linear factor. We can't get linear factors from this particular quadratic expression. So it is an irreducible quadratic factor. So we need to use linear expression of the form ax plus b to separate it. So here we also have linear factor, and the linear factor is x minus 3. So how do we separate a linear factor? We use a constant to separate a linear factor. So using this constant here, we have a, b. We cannot use a again. So in alphabetical order, we are going to have a, b. The next common letter to use is c. That's the reason why we have c divided by x minus 3. Now, in the same order, multiply the denominator by each term. When you multiply the denominator by this term, you get this answer, because this whole thing will cancel it when you have 2x squared minus 11x plus 5. You do the same thing, we are going to have ax plus b times x minus 3 plus c x squared plus 2x minus 5. The next thing is to find the constant a, b, and c. So we can let s to be 3 in order to cover up a and b to get c. In doing that, we are going to have an expression of this nature. Anywhere we see x, we put there 3 there. So 3, 2 times 3 squared minus 11 times 3 plus 5, and so on here at this particular section. So we have 3 squared plus 2 times 3 minus 5. Then we are going to have minus 10 equal to 10c. When you simplify the left side and the right side, that is what we are going to get as our expression or our answer. Then divide both sides by 10 to get the c, and c is equal to -1. We can also let s to be equal to 0. The moment s becomes 0, what is the meaning of that? It means we are going to have 0 of this expression, that is 2 times 0, 11 times 0 plus 5 equal to a times 0 plus b, this times 0, and so on. And as such, we are going to have -5 equal to -3b minus 5c. Remember, our c is equal to -1. So if c is -1, we can put c here, which will give us 3b equal to 5 minus 5 and 3b equal to 0. So b equal to 0. Then we can also expand this term as this, then compare coefficient like the way we are doing it. So expand this term, we have ax squared minus 3ax plus bx minus 3b. Then expand this one, we have cx squared plus 2cx minus 5c. Then that will give us 2x squared equal to a plus cx squared, because the coefficient of the x squared at the left hand side is 2. So we can equate them as 2 equal to a plus c. Then 2 will be equal to a minus 1, because c is -1. Then our a will give us what? 3. So as such, the expression will be rated as 3x squared minus 11x plus 5 divided by x squared plus 2x minus 5 times x minus 3 is equal to 3x divided by x squared plus 2x minus 5 minus 1 over x minus 3. So you just have to substitute the value of a, b, and c as where they are supposed to be. So now there is a practice section for you to try your hands on them. We solve the following rational functions into partial fractions as you see here. So deal with them. Try your hands on them. Pause the video and send us your solution for us to verify and go through and help you to understand this simple high school mathematics concept on partial fractions. Now let's proceed to the next one, where we are going to learn on how to decompose rational function with repeated factors. So now, decomposing rational fractions or functions with repeated factors. When a rational function has a repeated factor, such as x plus a all square, a repeated linear factor, or x squared plus b all square, a repeated quadratic factor, then each power of the repeated factor gets its own term in the decomposition system. So here, for a repeated linear factor like x plus a all square, we use a divided by s plus a plus b divided by s plus a all square. So we use constant. So the idea about this study is for you to understand that the moment you have a linear factor, use constant to separate them. But saying this one is a repeated factor, I'll use constant a to separate one linear factor with exponent 1 plus b, that is a constant, to also separate s plus a exponent 2 and so on. It repeats like that. So if this particular linear factor was supposed to be power 3, then the next one will be a constant c divided by s plus a all power 3 and so on and so on. Now, for a repeated quadratic factor like this, ask yourself this question. What format of expression do we use to separate a quadratic factor? We use linear. So here, I'm going to use linear expression of as plus b to separate the quadratic factor x squared plus b power 1 plus continue another linear factor cs plus d divided by x squared plus b all power 2. If the power was to be 3, the next one will be es plus f divided by x squared plus b all power 3 and so on and so on. So the concept is we use constant to separate linear factors, and we use linear to separate quadratic factors, as you see here. So now let's proceed to understand a simple example. So we solve the rational functions 1 divided by x minus 2, x minus 1 all square into partial fractions. So now this is a proper rational function and I can separate it. But look at the denominator. We have linear denominator here and linear repeated factor as part of the denominator. So linear factor as a part of the denominator and linear repeated what factor. So here, this is how we are going to separate it. What do we use to separate a linear factor? We use constant. So the constant a divided by s plus 2. Then we have linear repeated factor. Since it is linear, I'll still be using a constant to separate s minus 1 power 1 plus another constant c divided by s minus 1 power 2. So that is how it's supposed to be. Then multiply each term by the denominator of the rational function. Then we are going to end up with 1 equal to a s minus 1 all square plus b s plus 2 s minus 1 plus c s plus 2. Then we are supposed to let x equal to minus 2. Why? To cover c and b to get a. In doing that, we are going to get 1 equal to 9a, divide both sides by 9 and you get a to be 1 over 9. Expand each term at the right hand side, then the expansion will be done in its simplest form as this. So I'll first take this one, a s minus 1 all square. Expand the s minus 1 all square like this, then expand it in this format. So I'm going to get as square minus 2as plus a. Then I'll take the next one, which is b s plus 2 s minus 1 in this format. The same thing, I will expand this before multiplying the b. Then when you expand and multiply the b, we have b s square plus bs minus 2b. You take your time, then you do it nicely. Then I'll take the last one, c, which is c multiplying s plus 2. That will give us cs plus 2c. So I'm going to sum all these expansion and group like terms. So grouping like terms will be, I'll group the as square and the bs square as like term, minus 2ax, bx, and cs as like term, the constant a, minus 2b and 2c as also a like term. In doing that, I am going to have 1 equal to This is nicely grouped. We have a plus b all x squared plus minus 2a plus b plus c all x plus a minus 2b plus 2c. Then you compare coefficients at both the left hand side and the right hand side. So now what is the x squared term here? X squared term here is 0. So a plus b is equal to 0. So I can make my p the subject. So it means b is equal to minus 1 over a. Then look at the s term here, it's also 0. So minus 2a plus b plus c equal to 0. So I have my a, I have my b. I can substitute the a and b here in order to get the answer for c. In doing that, my c will be equal to, that is making c the subject, will be equal to 2a minus b, equal to 2 times 1 over 9 minus 1 over 9, and my c will give me 1 over 3. All what I need to do is to substitute the a, b, and c respectively at where they are supposed to be. And our final result is going to be a as 1 over 9 x plus 2 minus 1 over 9 x minus 1 plus 1 over 3. Remember, a is 1 over 9, b is minus 1 over 9, and c is positive 1 on 3. And this simplified the solution for the separation of simple fractions of this particular rational fraction or function. So now let's proceed to work example number 2. We are to resolve partial fractions x squared divided by x plus 1 all power 3. Now this is a proper rational function and or fraction, so we can decompose it. So here we have x squared divided by x plus 1 all power 3. It's a linear repeated factor, so we are going to use constant to separate the linear factors, and the linear factors will be x plus 1 power 1, x plus 1 power 2, x plus 1 power 3. So we are going to get a divided by x plus 1 plus b divided by x plus 1 power 2 plus c divided by x plus 1 all power 3. So multiply each term by the denominator of the rational function. Then we end up with x squared equal to a x plus 1 all squared plus b x plus 1 plus c. So here let's x equal to minus 1. Why? Because when s is minus 1, we can cover up a and b to get c. So here c is equal to 1. That is the meaning. Then we expand the right hand side. So how do we do it? First, take the first one, expand the bracket first before you multiply the a across, and that will give us as squared plus 2as plus a. So when you expand this one, you're going to get s squared plus 2s plus a. So before you multiply the a across and get this particular result, then take this one to b times s plus 1, give us bs plus b. Then you group like terms, grouping of like terms. So the grouping of like terms will be x squared equal to as squared plus 2a plus b. Why? Because we have 2a here, we have b here. They are all marked with a variable x. So we just factorize the x outside and put them in the bracket of this in this particular format, plus the constant, which is a plus b plus c. So when you compare the right hand side and the left hand side, then we are going to analyze that s squared is here, s squared is here, so their coefficients are the same. So a will be automatically be equal to 1. So if a is 1, let's look at the next ones too here. We can also have 2a plus b equal to 0 because there's no constant coefficient of x here. So 2a plus b is 0. I'll just have to put the a here, then make b the subject. So b is equal to minus 2. So as such, this particular rational function or fraction can be splitted as x power 3 divided by x plus 1 power 3 equal to 1, that is a is 1, then minus 2 because b is minus 2, so it will affect the plus sign here. So divided by x plus 1 power 2 plus c is also 1, so we have 1 divided by x plus 1 all power 3. Now, that is how we've been able to split this particular rational or resolve this particular partial fraction. So here, there's a practice section for us to try our hands on it. So try decomposing the following. So we have this particular question for you to try your hands on them. So pause the video, try your hands on this question, then send us your feedback. That is the right place for all high school students to understand the concept of high school mathematics.